EIGRP is certainly a powerful routing protocol. How do we characterize it? Well, we would characterize it as a distance vector protocol. We say advanced. Does that really do it justice? In my opinion, no, it doesn't. I call it a hybrid. Because what does a hybrid car do? Let's say you're shopping for cars and you look at a hybrid. What is a hybrid car? It runs on both electric and gasoline. Well, they're saying a similar thing about EIGRP here. Distance vector and link state behaviors. Distance vector is really chatty. It doesn't understand the topology very well. Link state knows the topology really well, but it's sometimes a little too formal, a little too black and white. And EIGRP sidesteps the pitfalls of really both of these camps, chooses its own pathway, and that's either advanced distance vector or hybrid, however you want to call it. EIGRP is faster if you give the right setup than any other routing protocol out there. Why? Because it in fact can reconverge without a recomputation. The backup pathway is tested. The backup pathway has a name called the feasible successor. Partial updates. We don't send our entire routing table like a distance vector routing protocol would. We have a sophisticated metric. Ooh, sophisticated. What does that mean? Well, let's in fact look at what a metric of EIGRP might look like. And so we'll go here and I'll just look at my topology table. And what we can see is that we've got large values. So this is a metric. It's the feasible distance, which is what we call EIGRP's metric. That same metric would go in the routing table for this network. So let's look at 172.16.33.8. If that's in the routing table, is that really the metric? Well, let's do a show IP route, EIGRP, and what was that network that we were looking at? It was the .8. It was one of our WAN links right over here between R6 and R7. So I'm going to look for that network. Yep, same value. Same value. It's a large value. It's a 32-bit value. And what it does is it takes in a lot of components. I'll actually show you those. So if I do a show interface, EIGRP's metric looks at bandwidth and delay by default. It can also factor in reliability, load, and MTU can be a tiebreak. So I would say, yeah, that's a really sophisticated metric. VLSM support. Wait a minute. What is VLSM? It's not subnetting. It's a kind of subnetting. When we teach you subnetting, we teach you about breaking up a network into multiple subnetworks, right? Well, let's say we have the 10.1 space, and that's assigned to us. We are assigned to the 10.1 space. And we've got to take advantage of that and use it to address a full subnetwork or a full site with many subnets. Now, first, understand that that is a subnet. Why? Because the classful mask would be /8. This is a non-default mask. That means it's subnetted, without a doubt. We can go to ourselves, well, if I want to make the best usage of that, what I could do is this. I could say, I'm going to subnet that, and I'm going to use a variety of masks. I'm going to say my VLANs are going to get a /24 mask. My WAN connections are going to get /30 for point-to-point WAN connectivity. For connectivity where I need maybe 6 hosts, I'll use /9, so public. But this is a private space, so I'm not going to worry about that. Let's use something maybe a little bit more realistic for wireless LANs. Let's say a wireless LAN is going to be a /26. So you look at that and you go, well, wait a minute, Dan. That's different masks. Am I going to be able to pull that off? Well, I can only pull that off if I have VLSM support. How do we pull off VLSM support? That is demanded by a classless routing protocol. So is this a classless routing protocol? You betcha. How do we know that? I can do a show IP protocols, and I can look and see this. Automatic summarization is disabled. That means I can do VLSM support, and I have full capabilities of running as a classless routing protocol, and I'm okay. RIP v1 doesn't support VLSM. Why? Because it doesn't advertise the mask. In any case, EIGRP is classless, so we're good to go on VLSM support. Multiple network layer support. What are we talking about there? We are talking about the capability of EIGRP to carry IPv4 routes, IPv6 routes. It could also cover AppleTalk and IPX, not like you want that. And it'll run across your Ethernet WANs, your frame relay WANs, your PPP WANs, your MPLS networks. So we've got the compatibility with our infrastructure as well. So EIGRP, full-featured. There's a lot we can do with it, and there's very little we cannot do with this protocol.